Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so question 5, 2014 sample paper was some drawing of some trig functions. So the diagram below shows the graph of the function f of x maps onto sine of 2x. The line 2y equals 1 is also shown, which is the dotted line. A, on the same diagram above, sketch the graphs of sine 2x and 3 sine 2x. Indicate clearly which is g and which is h. Okay. So yes, it's a function. Yes, you can put into your calculator. No problem at all. That is a perfectly acceptable way of doing it. Okay. What is a little bit difficult about putting it into the calculator is coming up with the angles to go with. Okay. And this is 3 sine 2x, for example. Okay. What angles do I pick across here? Okay, so that can be a little bit difficult to come up with, not impossible. And again, I will do one or two with you where we will come up with the table to show you how to do them. Okay, you just need to be careful when you're picking your values that you don't miss the peaks or the troughs. Okay, so how would I do this one then without using a table? Well, because they've given me a wave, I would use that as my guide. Okay. So this wave here is sine 2x. So a couple of things I notice. The number in front of it is actually 1 sine 2x, okay? So that's why the graph goes up to 1 max, okay? And it's symmetrical, so it goes down to -1. The 2x in it here means there's 2 cycles within one 2 pi window, or 360 degrees, but 2 pi because it's drawn in radians. So there's one cycle to pi, and there's the second cycle to 2 pi. Okay, so that's what that 2 means. So this is b sine cx, okay? So amplitude and number of cycles in the window. Okay, and when I say the window, I'm always talking about 2 pi or 360 degrees. Okay, so what? Okay, well, I'll compare the two graphs that I have to draw with the one that I'm given, the sine 2x. And the first thing I see down here is sine 2x, okay? So that means that the wave crosses the x-axis at the exact same points because the 2x matches the 2x. For this one, there will also be 2 cycles in the same 2 pi window. So if that's the case, then it has to cross the axis at the same points to fit in the 2 cycles, okay? So what's different? Well, the piece that's different is the amplitude, the 3, okay? So to draw 3 sine 2x, where the peak of sine 2x was 1, the peak of 3 sine 2x will be 3. And in the same way, the trough or the negative peak will be -3, okay? So what I do with it, let me draw it in, I'll draw it in red because it's a strong color, okay? Well, I'll draw it in pink to match what I'm doing. What I draw is I draw the peak up here. So if you can see what I'm doing, I'm going directly up from where I am. And in the same way with the trough, I'm going down here. Crosses the x-axis at the exact same points. Okay, and it'll cross here. This one will go up to 3. It'll cross here. It'll go down to here. It'll cross here. And it'll go up to here. Okay, so they are, when you're drawing a wave, you need the peaks, the troughs, and what's called the zero crossings. Okay, and then as best you can, you keep your hand as smooth as you can and just hit off all of these points. God, I picked a light color. All of these points. Oop, bit of a speed wobble there. Okay, I'm not the best drawer. Okay, and that one is h of x. Okay, so I hope that makes sense. Okay, so apologies for the wibble wobble, but anyway, it follows this one perfectly, except it's just much bigger. Okay, it's a much stronger signal. Right, let's draw sine 3x, okay? No, sorry, sine x. So sine x means the amplitude is 1. Can you see that? Okay, there's no number in front of it. The b is 1. And I have just one cycle within the 2 pi window. So sine x, okay? So I'm comparing it to b sine cx. So b, my amplitude is 1. And c, which is 1, which is the number of cycles. Okay, so again, I put in my zero crossings and my peaks and my troughs. Okay, so my zero crossings, if you see a sine wave, it starts at 0 and it finishes at 0. So the first 2 points I tend to put in is that 0, the starting point, and the end point 2 pi. Okay, now a wave is fully symmetrical, so at the halfway point, half the wave is done. And then you go into the negative half wave, okay? So by halfway between here and here, which is this point, my wave should be back down again and about to turn, okay? So there's a zero crossing there. And then of course, halfway between these, if I break it up into quarters, you can see a quarter of the way along, I'm at my peak point, okay? So halfway between these two is quarter of the full wave, okay? So that's halfway between 0 and pi. So what I do is I put a dot, kind of the peak of my curve up there. And in the same way, I find halfway between pi and 2 pi, which is here. You see, I'm all the time using this one as my guide. And I come down to -1 and I draw my trough, okay? So up, around, oh, did it again. Okay, and then in green, let's label him g of x. Okay, so I hope that makes sense. On the same diagram above, sketch the graphs of g of x is sine of x and h of x 3 sine 2x. Okay, part B of this question, find the coordinates of the point P in the diagram. Okay, so point P is here. Okay, I'm going to delete off around it a small piece. No, in fact, I'm going to delete it off altogether because this is in the recording, because I want to show you a few things about P. Okay, so P, if you look closely at this diagram, P lies on this function, which is f of x, which is sine 2x, but P also lies on the other line, 2y equals 1. So the point P is the point of intersection of these two lines, or where these two lines equal each other. Okay, so let me write that down. 2y was equal to 1. And y was equal to f of x, okay? And f of x was sine 2x. Okay, so P is the point where these two equal each other, okay? So y is f of x, okay? So I'm going to write him in terms of y. So y is equal to 1/2, okay? So if y is equal to 1/2 and y is equal to sine 2x, well then sine 2x must also be equal to 1/2, okay? Because both of them equals y, okay? So point P is the point where these two lines equal each other. Now, what I want to draw your attention to is the fact that there are many points where that line 2y equals 1 equals f of x, okay? So we have to find this particular one here. That's the point P. But there's obviously going to be more solutions to where those two lines equal each other. Okay, so what this actually is the same as the reference angle ones we've been doing. Okay, with cast. Okay, so we're finding all of the solutions where sine 2x equals a half. Okay, so just like before, we get our reference angle. Okay, so get the sine inverse of both sides. So you're left with 2x being equal to sine inverse of a half. Sine inverse, I'm just going back to see is it in radians or degrees. So it's radians. So let me check my calculators in radians. It is. So sine inverse of a half. And I've got a 1/6 pi. Okay, let's draw my cast. And I'm looking for what quadrants is sine positive, okay? Because this is a positive number. So this angle sine is positive and this one sine is positive, okay? So sine positive. Okay, so quadrant 1. So first quadrant, 2x is equal to a 1/6 pi. And in the second quadrant, 2x is equal to, this is pi here, pi minus a 1/6 pi, which is equal to 5/6 pi, okay? Because remember, it's always with respect to the horizontal. That's why we've subtracted off that 6 pi. Okay, so then we write it in general form. So I have a 1/6 pi, well, sorry, let me write the 2x equals. 2x equals a 1/6 pi plus n2 pi, or 2x is equal to 5/6 pi plus n2 pi. Okay, divide across by 2 because we want to solve for x. So x is equal to a 12th pi plus n pi, or x is equal to 5/12 pi plus n pi. Okay, and then let's solve. So n is equal to 0. So I'm going to do it twice. You always match the number here. So n is equal to 0. So x is equal to a 12th pi. N is 0, so this disappears. And over here, x is equal to 5/12 pi. For the same reason, n is 0, so this disappears. Okay, doesn't disappear though on n is equal to 1. In this case, x is equal to a 12th pi plus pi, okay, or I should sub in the 1. What I'm doing is I'm subbing in 1 here into the general form. And over here, x is equal to 5/12 pi plus 1 pi. Okay, so x is equal to here. So I look at that as 12 twelfths. So that's 13 twelfths if I add on the other one. And this is equal to 12 and 5, 17/12 pi. Okay, so within that, 0 is less than or equal to x, I'm calling it, is less than or equal to 2 pi window. I have 4 angles. I have a 12th pi, I have 5/12 pi, I have 13/12 pi, and I have 17/12 pi. Okay, so let me go back now, and this is why I cleaned off the diagram. So there's your a 12th pi. This is your 5/12 pi. This is your 13/12 pi. So P is 17/12 pi. Okay, so P then, coordinates of P, I'll write them here because you can see it. So coordinates of P, X value, comma, Y value. Okay, because it's easy to see that the Y value is a half. So that's how you do that one. We only looked at 0 to 2 pi window. That's why we don't have an answer for him. If we start to sub in n is equal to 3, then, no, sorry, the next one, n is equal to 2, then the first answer we get there would actually be that blue dot. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.